Okay, student, this is the 8th question. It is about an astronaut moving in 15 meters per second toward the space station. Its velocity is 0. Now, his velocity is 15 with respect to the station. He go toward the station in 15 meters per second, and its velocity for this system is 0. He will hit it and then reflect from it with final velocity. We need to find this final velocity for the astronaut. It is easy. We don't have the mass of the station. We don't have the final velocity for it. We assume that it is at stationary point initially. The momentum will be conserved always. So the momentum initially is the momentum for the astronaut, which is m1 v1 initially, plus the momentum for the station, which is m2 multiplied by its velocity. Its velocity is 0. So the initial momentum for the station is 0. Then our system has the momentum of the astronaut, which is m multiplied by its initial velocity, which is 15. Finally, we have the momentum of the astronaut after the reflection process and the momentum of the station. So we have m1 v1 finally plus m2 v2 finally, but the station is very huge. Imagine that you hit a football by, for example, by a car. The football will not affect the velocity of the car. Its velocity will stay stationary, and the football will reflect on that car by the initial velocity. So its velocity after this collision with the astronaut, it is nothing. It goes to 0. It will not move in that direction. Okay? Because it is a huge, it is thousands of kilograms. Okay, so the momentum for the change in momentum for the station is 0. Then its velocity after the collision will stay 0. So the momentum for it will be also 0. So the momentum before is from the astronaut, and after it is the same from the astronaut. There is no gain or change or lose in the momentum of the station. So we have the momentum before, which is m1 v1 initially, is equal to m1 v1 finally. We don't know the mass of the astronaut. We don't need it because we can cancel it from both sides. We know the initial velocity. It will be equal to the final velocity in magnitude, which is 15 meters per second. But in physics, we know that his velocity will be in the opposite direction. So we can put a minus sign in the final answer, or we can write in the opposite direction. Okay, and that's it. Thank you.